All right, in this video we are going to write a recursive method that returns a Boolean value if its string parameter is a palindrome. So that's kind of awkwardly worded, but right, it should return true, the Boolean value true, if the value of the parameter is a palindrome, okay? And if it's not, then it should return false, right? Okay, so let's go ahead and take a look at this problem, right? So if you have something, let's say a palindrome, like the word radar, that reads the same forwards as backwards, right? What you're going to do, essentially, right, when you do this, or one way to do it, right, is to check the first and last elements, right? And they would have to be the same. So if the first and last ones are the same, right, then what we're going to do is we are going to then look at the next two. So we would basically then just look at this smaller part. So if the first and the last characters are equal, then it's just a matter of checking the string with the first and last characters removed. Okay? And then again, we would just repeat that process, right? Check and see if these things are the same, right? If they are not, right, then we know that this would not be a palindrome, right? If they are the same, then we would peel those off and look at the smaller string, right? In this case, it's a one-letter string, right? Okay, and a one-letter string is a palindrome, right? It's the same forward as backwards. We don't really even have to check, okay? So if the length of the string that we're given is 1 or less than 2, if you want to do it that way, then it is a palindrome, okay? Or that would be a palindrome, so we would return true on that, okay? All right, so let's take a look at how we would set this up. Oops. All right, so start a new class, and we'll make the name of the class is palindrome. And put a main method in there, public static void main string args. And then we're going to need some test case, but let's worry about that after. Let's do another method, public static. And all right, this one's going to be Boolean, so it returns true or false, right? And we'll call this one is palindrome as well. Its parameter, right, is going to be a string. We're given a string and asked to decide if it is a palindrome. All right, so we're just going to go character by character, right? We could make this more complicated, but we're just after writing a recursive program, and so I just want to try to keep it as simple as I can. Okay, so the base case, like I mentioned, right, is that if the length of the string that we get is 1, then we know it's a palindrome. So we would return true in that case. All right, in the example that I gave you, this was an odd length one, right? And so if you have an even length palindrome, this process, right, the very last string will be the empty string. And so what we want to do then, if it's the empty string is a palindrome as well, sort of by default, right? It has nothing in there, so it is kind of the same forward as backwards. So to take care of that case, we'll just say that if the string's length is less than 2, right, it's automatically a palindrome, okay? So if we have an example here that says, if we do system.out.println is palindrome the empty string, or system.out.println is palindrome with a single character, these should both return true, although I think this one is going to complain when we compile it because there's no return statement. That's outside of this if. So if we add an else, which we will at some point, right, then let's just put return false here to make Java happy, and then we'll go back and straighten it out. Also, I can see here, right, that this should be, since we're talking about strings, its length is a method, so it needs the parentheses. All right, so you see we can get true for both of those, okay? All right, so next up, right, what we're going to do is do exactly what we did here, right? When we have a palindrome, or when we have a string that's of length more than 2 or more, we are going to pull off the first character and the last character and compare those, okay? So there's a number of ways you can do that. I'm just going to use char at, all right, because we're just pulling off one character at a time. All right, so s.char at, the first character of a string would be 0, right? And if you're using char at, that returns a value of type char, right? And so with type char, which stands for character, right, or short for character, then you can use double equals to compare those reliably. So because it is a primitive type. And so now I just need to pull off the very last one. The very last one is going to be s.length minus 1. That's the character at the last index. So this is saying if the first character is equal to the last character, right, then what do we want to do, right? Well, actually, it might be a little easier if we said if it's not equal to, right? If the first character and the last character are not equal to each other, right, then 100% we know that it is not a palindrome. So we would return false. On the other hand, if they are equal to each other, we don't know that it's a palindrome, right? So what we would do is check the substring, just like we did here in the example. What we would do is take the string, right, that consists of everything but the first and last character, all right? So what we would do, and then call the method again. So in that case, we would return whatever value we get from calling the isPalindrome function itself with a substring, right, of our input string, and that substring would be starting at the character at index 1, not the first character, right, but the one after the first character, and then going all the way out to the length actually, yeah, so this would be the last character. The index of the last character is there. And now you may say, hey, I don't want the index of the last character, but the way substring works, it won't actually take this very last one itself. Okay. All right, so then we're going to pass that substring to the isPalindrome method again, and it's going to go all through this again. But each time, right, we're doing that, it's a smaller string, right? And so it's getting closer and closer to the base case being that the length is less than 2. Okay. All right, let's put some other test cases in here. Let's do radar and Abel was I air I saw Elba. Those both should be palindromes. One more palindrome, Madam, I'm Adam. And then some non-palindromes. one more. And one problem, with our implementation that we have is that, for spaces and punctuation, it's not going to work correctly. So we should get 3 trues and a false. And I keep forgetting that last parenthesis here. Three trues and 2 falses, right? These 3 are palindromes, right? This one is definitely not a palindrome. This one actually is. If you take the spaces, if you don't consider the spaces and the apostrophe in there, it is a palindrome. And another thing is our implementation doesn't account for upper or lowercase letters. We could add all that stuff in there if we felt like it, right? But we're not going to worry about that. We just want I want to do this in a recursive way because that's what we're talking about, recursive methods. So just to recap, right, what we do is if the length of the string, the input string, is less than 2, that means it's either the empty string or a 1-character string, right? And so therefore it's automatically a palindrome, right? We return true, and that's our base case. Otherwise, right, if it's 2 or more characters, right, then what we do is we look at the first and last characters. If they are not the same, then it's automatically, we know that it's false, right? That it's not a palindrome. And then otherwise, what we do is call the function again. In this case, right, we peel off the first and last letters, which at this point would be the same, and just look at the part in between the first and last letters. And then we send that back to the function again. So that's the recursive call, right? Each time the length of this string is getting smaller and smaller. So eventually, right, it will get down to where the length is less than 2, and it will that will stop the recursion. Okay. All right, that is it on this one.